Hello all, welcome to yet another video from this series called Triangle Basics. In today's video we are going to understand incenter. What is incenter? It is a point that lies inside a triangle. No matter what kind of a triangle, this point will always lie inside the triangle. It is a point where the angle bisectors of the internal angles of a triangle meet. Let us see this figure, which might just give us some more insight into what really we are talking about. So we have this figure, looks familiar. Yes, we have a circle inscribed in a triangle. As you can see, the center of this circle is named I. Well, this is the incenter. What is fascinating about incenter is that it is also the center of the largest circle that you can draw inside a triangle. So a lot of dots will connect them all. Overall, incenter is what? It is a point that lies inside a triangle where all the angle bisectors of all the three angles of a triangle meet, and this point also happens to be the center of the largest circle that you can draw inside this triangle. In other words, no other circle larger than this can fit inside this triangle. That's what it means. So we have talked about the what of it. What is incenter? What is incircle? Well, this circle, by the way, is called incircle. What is incenter? What is incircle? Now we will try and understand how this really happens. So we are going to analyze this overall thing called incenter in a few steps. The first step, we will try and understand how to draw the angle bisector of a given angle. So in this case, we have an angle ABC, and we will draw the angle bisector of this angle. So in this case, with B as center, as you see, and any convenient radius, cut an arc on the line, on the arm AB, without changing the radius. Mind you, without changing the radius, we will draw another arc which cuts the other arm. So we now have two arcs. Now these two arcs must be drawn with the same radius. Now in the next step, what we do is we move the center to these arcs, and maybe without changing the radius, or you have a choice here depending on whatever is convenient. You may just draw arcs once again, and over here there is another arc that we draw. So we have two sets of arcs. The first and the second must be of the same radius, and the third and the fourth, which we are drawing now, must also be of the same radius. So now that we have these arcs, let us join this point of intersection of the third and fourth arc. I'm talking about this point with the vertex B, and this line is the angle bisector of angle ABC. So overall, ABC is the original angle or the earlier angle that we have, and these two angles that we have now got are equal, and they are half. Each one is half the original angle. That's what a bisector means, angle bisector I mean. And now we go on to the next step. In the next step, we have the angle bisectors of all of these angles drawn. So in the previous set we saw how to draw an angle bisector. So going by that, we have drawn three angle bisectors. For the three internal angles in a triangle, we have three angle bisectors, and these bisectors happen to be AX, BY, and CZ. Now these three bisectors, they meet at this point I, which is called the incenter of the triangle. So you see, the point where the angle bisectors of the three angles of a triangle meet, that's called the incenter. We now get on to the next step, and in this we now draw perpendiculars from the incenter I to the three sides AB, BC, and CA. Why we are drawing these perpendiculars will be relevant, will be obvious, will look obvious in a while from now. We'll see the relevance of this in a while. For now, what we have done, what we have drawn perpendiculars ix, iy and iz. Now interestingly, when you draw a circle with I as center and iy or ix or iz as radius, you will get a circle which happens to be the incircle. Interestingly, this circle is completely inscribed in the triangle. This circle is called the incircle. Now for this to happen, how has this happened? First of all, this must have happened, this can only happen, this can only happen, let me write let me write this down. So this can happen only if ix is equal to iy is equal to iz. Well, this has happened. We haven't done anything, as you have seen me doing this construction. We have done nothing to make these line segments equal, but they turn out to be equal. How can we say they are equal? Because the points x, y and z, they all lie on the triangle and they all lie on the circle, which means ix, iy and iz are radii of the same circle and they must be equal. So now we will analyze, we will establish how these three line segments ix, iy and iz are equal. So in this case, we considered these two triangles. We take triangle CIX. Let me just shade this for now so that we are able to identify this easily. So we are talking about triangle CIX and triangle CIY. So we're talking about triangle CIY. So the other triangle that we are talking about is this CIY. We will see if we can prove them congruent. So in these two triangles, we see that angle ICX is equal to angle ICY, and that is because CI is the angle bisector, of angle C. Yes, also angle IXC is equal to angle IYC because both are 90 degree. Also CI is the common side, and hence we can conclude that triangle CIX is congruent to triangle CIY, and that is by AAS congruence. Once this has happened, we can conclude that IX is equal to IY, and that is CPCT. Now if we do the same analysis for these triangles, if we are talking about this as the angle bisector BI, and if we take these two triangles 1 and 2, we can prove in the same way, we can prove that triangle 1 is congruent to triangle 2, again by AAS congruence, and that would get us IX is equal to IZ. So from this and this, if you combine the two, you would see that IX is equal to IY equal to IZ. So whatever we said must happen has actually happened. This is how we have mathematically proved or derived the line segments IX, IY and IZ to be equal. No wonder we are able to draw a triangle with center, we are able to draw a circle, I beg your pardon, we are able to draw a circle with center I and radius IX, IY and IZ. So overall I, the incenter of the triangle, is the point where the angle bisectors of the three angles of the triangle meet, and this point also happens to be the center of the largest circle that one can draw inside the triangle. The circle is called the incircle. Thanks for watching.